Oh yes. Holy, holy. Blessed. Tôi bị khóa thế này hả mà? Pro sao bề này? Tôi bề musuh asam kaya lagi. Hello, boss. Are you doing civil engineering? Something civil engineering. France, country. FRANZ. FRANZ. As in France. Saying. ANZ. Do one day a course code of FT. F O. F. So you're supposed to do so F. For CV for each of these are something. One to meet never. CV for that's a it is each of them. So I asked someone and he said it's yeah. Which is here. Some are the right. So what is it? Well, it's supposed to be they all want to be online. So time right now, isn't it? Try to sign it. No, I've shifted it. I have to be doing something. Still, you need to do it. They brought it in. Okay. Thank you. France. Yes, mine is a bit. To place. Okay. No problem. It's a different person. Wasn't the last time? Yeah. I'm speaking to someone. CV. Oh, okay. Most of the years. Okay. All the rest. Oh, so much noise here today. Hey, what's going on? So much noise. I don't know quite why. Hello, anybody can hear me? Hello.
Hello, sir.
Hi, Grace. How are you doing? So can we start or what? Because I don't want anybody to be left out. Can we start or we should wait? so that you take the responsibility. Can we start? Nobody's minding. Nobody.
So we can start. The time is 2. Let's just start.
Okay, so if anybody complains, then I'll send them to you.
So, but record the class.
Okay, that's fine. Because so far I only have 7 people. How many are you in the class?
We're about 17.
Okay, that's fine. So much noise here. I wish I didn't. Anyway, so I hope you are following what we're doing. Many questions from last week. The last week, I think we kept on, hammering on the components of GIS, looking at them in, a single unit. We are looking at the hardware, mentioning some of them. Should we talk about the software? You should understand what data is, so yeah, we want to just continue from where we left off. We also touched on topology, and so let me ask you, what is topology? I'm curious. I want to find out if anybody has an idea. What is happening these days is that you teach and you ask a question and people don't have an answer for you. I don't understand what is going on. It's like it's trending, So I'll be asking a lot of questions from you. In your own words, what is topology? In your own words, what is topology? In your own words. So this one is, I'm having an interaction with you. What is topology?
Hello, sir.
In GIS, when we say topology, what is it?
Sir, let me give
Anybody at all? Are you out there or you're not there?
Sir, here, let me give it a try.
Say it again.
I want to give it a try.
Yeah, give it a go. Give it a go. I mean, try. It's better to try. Someone said it's better to laugh and lose than not to laugh at all. I'm talking to myself.
Okay.
Yeah.
I think topology describes how devices are connected and interact.
No, device. It's got nothing to do with a device. So you see, when someone asks a question, you need to look at the subject or the object. Are you okay? Of the question, and know exactly what to give back. Are you okay? What is the person asking about? What is the object? Then you can now describe it. Topology is about geographic features. So if you don't describe it as such, okay, there's an object that we are doing, and the object is a geographical feature. You can't say we are talking about buildings. You can't say we're talking about roads. You can't say we're talking about a farmland. We are talking about something like that, which can be generally be described. Okay, we can describe everything on the surface of the earth to be a feature. In geography, a tree is a feature, like what we say a feature, that's what we talk about. So geographic features, the relationship between geographic features. So first, that's just definition really. It's like define it, but what really does it mean? Having relationship between geographic features. So this one goes to Grace. Grace, because you are the only lady, I have to worry you. I don't want you to fail. Grace, is she gone already?
Yes, sir. I'm here.
Okay. So Grace, what is topology? In your own words, what does it mean? I want you to remember, Grace, that GIS is a system, and in every system, there has to be some kind of model, okay, based on which you are working. Don't forget that before you put up a building, there's a model. You see, sometimes I think we make teaching very difficult and we make learning very difficult. Truth is that you cannot put up a building if you don't have the model. The model is the design. So when I use the word model, and I'm not talking about generally things that are not physical per se, you should be able to explain it. What is topology? Why do we say is a relationship between features? Why do we say that? Why do we say that? I think there's no one here. I can take off the mask. Why do we say topology is the relationship between geographic features? What exactly do we mean by that? Saying that?
Thank you.
What exactly do we mean when we say relationship? First of all, let's give examples of geographic features. Michael, give an example of a geographic feature.
Example is a tree or a
That's
bird.
okay. That's okay. Next person, got told an example of a geographic feature.
Mountain.
That's good. Next person, go back. Google. Sobald, right. Sobald, right. Give me an example of a geographic feature.
Yes, sir.
Say again.
Yeah, as an example, we can mention a house.
House. Yeah, that's fine. Niama, give an example. There are thousands of them, so I'm just yes.
A mountain.
No, someone has already said mountain, please. So say something else.
Plateau.
It's all the same. It's a type of mountain. Go move away from mountain.
A basin.
You decided that you either be with the mountain or okay, that's fine. But it's correct. It's good.
Deserts.
It's fine.
Deserts.
It's okay. A desert area. Are you okay? A basin. Yeah, river basin. Are you all right? Okay. Christian. There are so many of them. Plenty. In fact, you can't even mention. You never finish mentioning them. Yes. Christian is gone. Gigo is gone. They are all not here. So they should know that I'm aware.
I'm here, sir.
Okay, go ahead. Let me hear you.
Sir, I'm here.
Okay, I'm listening to you.
A river.
That's good.
A river.
Okay, give another one. Christian, give another one apart from river. Huh? Someone told you, you didn't say it by yourself.
Oh, no.
Okay, then you should be able to give. There are a lot of them. You picture yourself.
I'm here alone.
Picture yourself driving on a road. There are so many things around you. Those are the features geographic features we are talking about. When you travel anywhere from Kumasi to Accra, everything you are seeing on your left and right, they are all geographic features.
Electric pole.
Yes, electric pole is one of them. Train station, train railway line. Yeah, airports.
Yeah.
So why are we struggling?
Even we the human being themselves to be apart.
A filling station.
Human beings. Okay, human beings, yes. Well, yeah, geographic features. You see, human beings are phenomenal. They don't stay at one place, they move. Are you okay? So they are objects in a way. They are objects. You don't really want to, look at human beings as a geographic feature, a human being. Are you with me? If you want like great examples, it's what is around you. So you are the subjects. Are you okay? You are the one looking at your geography. So don't really look at yourself. Are you okay? All right, anyway.
So a human statue.
So look at the physical stuffs.
A human statue.
Statue. Okay, that's fine. Okay, so when we say relationship between geographic features, relationship. So anybody Anybody? Mention your name before you answer, so that I can give credit where it's due. Yes. Geographic
A relationship between what?
Geographic features. What does it mean? Last week we talked about all this. I'm only recapping, so I'm not a stranger to you. Topic is not a stranger to you as well. Yes, what do we mean when we say relationship between geographic features?
Hello, sir.
Go ahead. I want to answer.
My name is Godwood.
Go ahead, go told. Yes.
If you say the relationship between geographical features, what it means is the way they respond, or they are, let's say, if you have maybe a mountain, you have trees. The mountain is there, the tree is there. They are how they connect.
How does a mountain connect to a tree?
For instance, maybe the land. Let's say the land, the tree is on the land, and then the land that gives a fertile or a food to the tree to maybe to grow. So
no, that is called. Hold it right there. Hold it right there. So that is called symbiosis. It's a biology concept. Are you okay? Phenomenal. Okay. So what you are describing, I can relate to it, but that's not what we are talking about. Okay, last week, what example did we give? Anybody in the class? What example did we give when it comes to topology? What was the example we gave? When it comes to topology, what was the example? The example to help you understand what topology is about. Because don't forget, we talked about different rules in topology. Are you okay? The different concepts in topology and the different rules under the concepts. Okay, so what was the example? What was the example given last week? What was the example? Sobalt, right. What was the example given? So I understand why people don't get answers right. What was it? What was the example given?
Yeah, I remember the last time we talked about the relationship between the topographic features by the way they relate.
I want one word. I want one word. Right. I want one word. We talked about one thing that was used to explain topology that brings understanding to what it is. What was that? Remember the road intersection? Have you forgotten? Were you here? So what? We talked about the interchange, Accra Mall interchange. We spend a lot of time on that.
Yes.
Yeah?
Yes.
Exactly. So this is something that you shouldn't forget, because as you forget and you go and Google what topology is, you'll be getting something else. And that answer is cost you zero. I'm trying to be honest with you guys. When under the pressure, you type in what is topology, what you get will be different from what we're talking about here. Okay, so please take note of that. So I encourage you to keep reading the previous lecture before you come to the lecture for the day. All right, so what is the relationship between let's say your project area and then the next property? So this question goes to the class in terms of, we are talking about topology. What's the relationship between your project boundary? You've been given an area to build a structure. What's the relationship between the boundary and then the property next door? Anybody to mention your name before you give the answer?
The line was breaking, so we couldn't hear. You said
okay, you couldn't hear me, not everyone. So let's be very clear on that. Okay, the question is that, what's the relation between your project boundary? You have a project to do, and the project has a bound. You have to know that as an engineer. What's the relation between that boundary and the next door, the property next door? Do you understand the next door, right? You understand that the property which is next to you, adjacent to your project. What's the relationship? We have topology in mind. So what does topology say about the relationship?
Sir,
If you don't understand relationship, I'll teach you what relationship is and what people who are in love. I will talk to you about.
The relationship the relationship between them is where each land where they meet.
Exactly, they share a common boundary, isn't
That is
it?
the relationship. Your boundary where you
They
are.
share a common boundary, yes.
Where they meet. That is the relationship.
Where they meet, where what meet. So come clear, as you always explain yourself very well. You realize that the next property always has the same, wall. The same wall is shared between properties that are adjacent. Is that not the case? So here we're looking at polygons.
Yeah.
Polygons that share boundary, that have the same side, common to them. Are you all right? And then we talked about, the line, when you have lines, arc node topology. So arcs only join at nodes. Okay, so the question here is that why do arcs need to join at nodes? Why is it important about that? Okay, what do arcs represent? An arc, what does it represent? ARC, arc, as we said last week. What do arcs represent in real life? An arc. It looks like this. It begins and ends on what we call a node. In real life, what are these? What are lines in real life? What are they? So this conceptually, a line, you can't go and tell someone a line. They will go, what line are you talking about? Are you okay? But then we sit in a classroom and then we talk about lines, but really we are referring to the real world, the built up environment. All right. So what do nodes represent? In other words, if topology rules, arc node topology says that arcs only join at nodes. In real life, what two things join that looks like linear, that look very linear? What two things join up at a certain place and are linear like this in real life?
Sir.
Yes.
Sir,
Mention it.
Gottwood.
Okay, Gottwood, that's good.
Gottwood.
Yes.
Maybe let's say a start of a plot of land, and where it ends before another person's.
In the real life, no, hold it, Gottwood. In real life, what is straight like that and begins and ends at one point? Mention something in the real world that looks like that starts and ends, but then can join something also, which is also linear. You see, you should get into the spirit of what I'm saying. Yes.
Hello, sir.
Yes, go ahead.
Christian.
Yes. Christian.
Something like a road, like a roadway.
Yes, so roads always meet
like
at
a road.
Yes. Okay, another one. I want two more examples. I want two more examples to that.
A building to.
No. Buildings are not linear. They are not like lines. Buildings are like polygons. Are you okay? That's why that will not be accepted as a good one. Buildings are like this. Are you okay? Meanwhile, pipelines are like this. Okay? Pipeline starts, they have to, your house has to be saved. So you can see that these are nodes that connect. This is how you analyze the flow and distribution of some sort of gas network, or are you okay? Some other resource, okay, that is being distributed via.
So electrical, is it electrical wires? Electrical wires.
Electrical networks, yes, electrical networks are one of them. Yes. Stars and ends. The beginning and end can be some sort of power source, power station, and then the end can be household. Are you okay? Please understand what I'm teaching you.
Yeah.
I'm teaching you geographical information
Yeah.
system. I'm teaching you things around us. Okay, that is all I'm teaching. I'm not teaching anything else. All right.
And
So,
real network.
okay, so I hope you understand. Yeah, real network is one of them. That's good. Christian, that's good.
Yes, sir.
Real is one of them. Okay. That's fine. So today we want to continue from where we left off, and we want to talk about layers. Is that okay? And I think last week, I don't know if I even touched on that, but we will carry on with it. So layers, the concept of layers, how does it work? We have to be able to divide, separate data into different layers. It's done in AutoCAD. I don't know if you are familiar with AutoCAD. Okay, we can separate data into different layers in AutoCAD. What is the importance of doing that? Once you do that, it means you can, recombine them, which doesn't sound right. Okay, but then that is, the essence of doing that is to be able to do what we call overlay analysis. Are you okay? All right. So before we left last week, I drew your attention to this diagram here. Trying to get it visible. And I even said that when you have layers, they look more like, the kebab stick. Are you okay? Kebab stick or something like that. And you can take it off one by one. Are you okay? You can decide to take the thigh of a chicken, which is roasted or barbecued or however you want it. Are you okay? Grilled, and then eat it straight, or you can cut it up and then you stick it on the what? Some kind of what do you call that? A stick or something like that. Okay. And then you take it off one by one. That is how layers are, or layers and overlay, map overlays. It means that for a particular geographic location, you can have so many layers. So as an engineer, look at it in terms of the design for a structure like AIT's CView campus. Look at the different floors. Are you okay? Every floor then becomes a layer with certain information and data. All right. So as you go first, second, third, you haven't left the place, but you are just changing your levels, but you are really the same place. You haven't left. Are you okay? So the last place you want to hide will be, a story building, because then you wouldn't have moved anywhere. You just be moving up and down. You'll be within the same geographic area. So we can stick up different layers of information, and then later on we can bring them back together in what we call map overlay or overlay analysis, if you like. Okay. So GIS provides the tools for us. GIS software, they will always provide the tools for us. It says here that the combination of several spatial data sets, points, lines, or polygons creates a new output vector data set. What does that mean? It means that you can actually decide to add separate points and then bring them back together. You can separate lines and then bring them back together. You can separate polygons. In fact, you can even try a combination of lines and polygons. Are you okay? All right. Now, when you do that combination, first you have to understand the fact that we can separate the data into layers. You can have a certain way of combining, the inputs. Are you okay? The inputs are whether you have some lines and you want to add them to points. So you can have what we call the union overlay. So union overlay combines two inputs and then you get a single new output. Are you okay? Then intersect overlay defines the intersection between two data sets. Then the symmetric difference overlay allow you to just keep the area except the intersecting area. Are you okay? So you keep the area between the two inputs except for the overlapping area. Okay, so I'll go over this again. And I'm going to go with an example this time. So if there's a concession, listen very carefully. And there's a project to be done. Remember, engineering is all about projects. So if you're an engineer and not getting the project, I don't know, maybe you're not an engineer, but there's a project, some kind of trench needs to be dug, whether for exploration purposes or whatever. All right, and then there is this blue area of interest. Something is going on there, maybe cool research or something goes on within this area. So we want to find out who will be affected, how much of it will be affected. Okay, so what we've done in this diagram is that we've actually added this data layer to that data layer. Okay, now this can be represented as a line or a linear, some kind of linear feature. And then this one is a polygon. So two data sets have been added, but then we are interested in this part of it. Are you okay? We're interested in this part of it. How much is it? How big is it? Sometimes we may be interested in who is going to be affected. So what the GIS software allows you to do is to then do an intersection. Remember that we've heard this word intersection before. If we will not be hypocritical, you agree with me that we've met this A union B before, isn't it? Haven't you? It's similar to it. Then you take everything. That is what A union B does, but that's not what I'm here for. But I want to be nice to you. That's why I brought it in. So you then combine everything if you are actually doing a union overlay. Okay, so in union overlay, you now have everything here. Have everything. Okay, that's A union B. That's it for you. Then if you want the intersect overlay, take the two inputs. So that's a linear project then again. And then you keep the common area. The common area is what you are actually interested in over here. Okay. So there you go. So that will be the intersect overlay. Is okay. So you keep the intersected area. So it helps you to decide, okay, which buildings will be affected? Should we compensate them? Things like that. This is how it should be done. You just don't go out there and then based on the color of the building, start pulling it down and say, I'm an engineer. From where? You understand what I'm saying? You should have done your analysis. Symmetric difference is saying that, okay, I'm not interested in, I hope someone is not sending me a message. I'm not interested in the intersection area, but you give me the intersection area and I know what I'll do with it. I don't want that anything else apart from the intersection area. So in that case, then what we are interested in is this area. So that's symmetric difference. So that can be very useful as well. Are you okay? So you can say, okay, anybody else? We are not interested in those who are going to be affected by the project. We are only interested in those who will not be affected. Sometimes that is also necessary. And because we don't do this, there's a whole lot of mayhem. The KJTR project, KJTR is a place in Ghana, in Kumasi, and there's a KJTR project, a new lorry terminal to be constructed, and a whole lot of, you ask yourself, have we even been to school before? Like the way it's done, no database, nothing. Are you okay? But